Hi, Jacob, Channy, and Diane.
Hi,
We miss you.
We still have that like useless math.
Yeah, the math stuff we don't need. Extrema.
Okay, actually, it is.
This is talking about max and mins. So the way Larson defines it, that we have a minimum when the value is less than all the other values. Right. So what this is saying, this is a minimum if it's the smallest value out of the whole curve. Okay? This is a maximum if it's the biggest value out of the whole curve. And you're going, duh. That makes sense. So the minimum and maximum are what they call extrema. Now there is also absolute mins and absolute max, and that only applies when there's no other value that's less than or greater than those. Now there is what we call an extreme value theorem, and this theorem, maybe, if f is continuous on a closed interval, then f has both a minimum and a maximum on that interval. They just say if you've got a closed interval, somewhere there has to be a min, and somewhere there has to be a max. All right? This particular theorem just says something exists. It doesn't tell you how to find it. All right, the definition of a relative extrema. Relative means it's local. Okay? So if there's an open interval and f of c is a max, then we call it a local or relative max. And if it's an open interval and you have f of c as a minimum, then it's called a relative or a local. Okay? Now, the plural is minima, and the plural for maximum is maxima. All right, so now critical numbers. Do you remember critical numbers from Saxon? It is a critical number if, when we take the first derivative and set it equal to 0, those values that we find are called critical numbers. They don't always make a max or a min, but they are critical numbers. So here we have a local extrema. Those occur only at critical numbers. So you're only going to have maximum and minimums where a critical number is. That's where the slope changes. So far, so good? All right, let's flip it. Let's look at guidelines. The guidelines for finding extrema. This is how we're going to do it. We're going to find the critical numbers, which we've already done before. Is that a fair statement? Then we evaluate each critical number in the original. We evaluate at each endpoint. You have to include the endpoints. I'm going to actually take f of c and tell me what it is, f of a and tell me what it is, and f of b and tell me what it is. The least value is what we would call the minimum. Sometimes the least value is at an endpoint. Sometimes it's not. Same thing applies for the maximum. Sometimes the least value is at an endpoint. All right, now here's I'm going to write the problem down and then this is not in your notes, these are examples. Okay? So here they tell us to find the value of the derivative at each of the extrema. Okay? So what I have to do is first take the derivative. What I'm going to first do is multiply this through.
Oh yeah, okay.
Might make it a little easier.
Yeah, okay.
Okay? Now we could do low d high minus high d low, or do you want to simplify that fraction even more? Couldn't we go 9 over x minus 27 over x cubed? So now let's take the derivative and we get negative 9x to the negative 2 plus, what is that, 81? X to the negative 4. Okay? Now the problem is I have negative 9 over x squared. I have 81 over x to the 4th. I need a common denominator. So I'm going to multiply this by x squared. Right? So now I have negative 9x squared plus 81 over x to the 4th. What part's going to make my fraction equal to 0? Top or bottom? Top. So now I'm going to set this equal to 0. 9x squared equals 81, x squared equals 9, x equals plus or minus 3. Okay? So they said, so we're just going to evaluate it at 3. Because they said to find it based on the picture, and the picture doesn't show it in the negative. Alright, so I plug in 3. Well, if I plug in 3 into this one, I get 9. Negative 9 times 9 is negative 81. Whoa, I get 0. Where does that point occur? Plug it where? In the original. So now I have 9 minus 3 over 27. 54 over 27, which ends up being 2. So you have a maxima at 3, 2. Max at 3, 2. Does that make sense to everybody? You're shown. Got it? Does that make sense? All right, I'm not going to do B and C. I'm going to move on to the next examples, okay? So let's go to the next example that says the following. Example 2 says f of x equals 3x to the 4th minus 4x cubed, and they want it on this interval. Can you see it? Now this is a polynomial. It goes on forever. It's quartic. So we're only looking at -1 to 2. Probably, and they want us to find both. So the first step is what? Take a derivative. So 12x cubed minus 12x squared, set it equal to 0, and now what do I do? Factor, 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 factor. So what are my critical numbers?
0, 1, and 81.
So 0 and 1.
Oh, because it's
Okay? The critical numbers right now that I found on the derivative is 0 and 1. But Derek, you're correct. The critical numbers are -1, 0, 1, and 2. Your endpoints are always critical. We now have to determine if they're...
I know, but like from solve. Oh, I know, because it's not x squared.
Critical numbers include the ones that equal 0 as well as your endpoints. Those are your critical numbers. Now we have to check which one's a max, which one's a min. Okay? How do you want to go doing that?
Second derivative test.
We'll go back to the original.
Dang.
So what I have here is f of x, and I am going to actually put x here. So I put in a -1, a 0, a 1, 2, and I actually plug in -1, and I'm going to get 3 plus 4, which is 7. Then I plug in a 0, and I get 0. And then I plug in a 1, and I get 3 minus 4, which is a -1. I plug in 2. 16 times 3 is 48. Minus 32. They're my endpoints. They told you. So if I plug in 2, I get 3, 2 to the 4th, minus 4, 2 to the 3rd, 48 minus 32, 16?
So, yeah.
All right, which one in this closed interval is your maximum?
216.
So your max occurs at 216, and which one is your minimum?
1.
Notice, you got a minimum on the first derivative value that you found, and you got a maximum at an endpoint. It actually goes like this. We have, these are 0, yeah, these are all, let's see if I can do this right. 1, 2, 3, 4, 5, 6, 7, and then I have 0, 0, 1, -1, but we added, and 2 and 16. This actually will go, you got a maximum here. got a minimum here. It actually looks like that. We need to find our critical numbers. First derivative. So I have 2 cosine x plus sine 2x times 2, because there's a cosine 2x.
Oh, it's 2x.
Set it equal to 0. Now it's very difficult to factor something like this. So what I'm going to do is use those identities, which is this part here is 2 sine x cosine x. So now I've got a 2 and I've got a cosine x. That makes this a 1 plus a 2 sine x. Alright? Can I set each factor now to equal to 0? Oh, thank you. Where is cosine x equal to 0? Pi over 2?
Yeah, pi over 4.
Pi over 2 and 3 pi over 2.
Yeah.
90 and 270. Pi and 3 pi over 2. Trig identities? Occasionally. Okay. 2 sine x equals -1, sine x equals -1/2. Where does that occur? That occurs down in these quadrants.
Both of them?
Yep, their sign is negative in both. So negative, this would be negative. It's 210. And you're all going, sure. Those are my critical values. All right, so here's my critical values, including my endpoints. How am I going to find my max and mins?
Wait, what? Is it from 0 to 2 pi?
Yep, so I have to go f of 0, f of pi over 2, f at 3 pi over 2, f at 7 pi over 6, f at 11 pi over 6, and f at 2 pi. Sine of 0 is 0. Boom, that one's gone. Cosine of 0 is 1. So this ends up being -1. All right, sine of pi over 2 is 2 minus, this goes, well, what's cosine of pi? So what's 2?
Plus 1.
All right. So now let's put in 3 pi over 2. That's 2 times -1 minus 6 pi. Because 2 times 3, oops, it's just 3 pi. So 3 pi, you go, where's 3 pi? Remember, 0 pi. Here is minus a -1, so I have -2 plus 1. That's 2 times, if you remember, 7 pi over 6 is here. So the sign of that was -1/2. Cosine of 2 times 7 pi over 6. No, it's 1/2.
Really?
It's 1/2. So now I have -1 minus 1/2 is -3/2. Now this is back over here. See where the triangular trig comes in handy? Sine of that, -1/2. What's the cosine of, well, 11 pi over 6 times 2. Where's 11 pi over 3? It's 3 1/3, right? 3 2/3. So 1, 2, 3 2/3 back down here. So, no, this is 60. So cosine is going to be 1 over 2. So what do we say? -1 minus 1/2? 2 pi is pretty easy. What's the sine of 2 pi? 0. What's the cosine of 4 pi? 1. So we get a -1. Which one is your max and which one is your min?
-3 is your max.
So here's a max. And you guess what? You have 2 mins. These are your 2 mins.